Hello everyone and welcome back. We are doing assignment problems. What have we done what are we doing in assignment problems? An assignment problem is a problem where a certain number of jobs is to be assigned to a certain number of people. The number of jobs and the number of people doing those jobs has to always be the same. You cannot have more jobs than the number of people, or you cannot have more people than the number of jobs. It should be, in other words, an n cross n matrix. It should be an n cross n matrix. So it should be a 2 into 2 or a 3 into 3 or a 4 into 4 matrix. 3 people, 3 jobs, 4 people, 4 jobs. 5 drivers, 5 cars. 5 jockeys, 5 horses. How do we solve it? Well, we solve it using the Hungarian method of assignment problem, where step 1 is row reduction, step 2 is column reduction, step 3 is assignment. In row reduction, we select the least from every row and subtract it throughout. In column reduction, which is if required, after row reduction, we check if every row has a 0. If every row has a 0, then we move on to column reduction. If every row does not have a 0, then we move on to column reduction. We check the least in every column and then subtract throughout. Step 3 is assignment. Once every row and every column has a 0, we start assigning. We did a couple of questions in that. Let's move on. And now what is going to happen is, I'm going to go back on my word. I'm going to whatever I told you is a lie. Well, not everything, but a few things are a lie. Number 1, remember I told you everybody can do every job. Well, what if there is a certain person who cannot do a certain job? So in an assignment problems now, we start adding one complication at a time. And complication number 1 is a prohibited assignment. Now, what is a prohibited assignment? Well, as literally as it sounds, an assignment that is prohibited. You are not allowed to make that assignment. Example, remember that machine and worker example that I gave you? There are machines that require the use of hands and legs both. Now, there is one worker who says that I can't work on machine S because it requires the use of hands and legs both, and I had polio, so I cannot work my legs well. Or there is a person driving, there are 4 people and 4 cars, and one person will say that that kind of a car I don't know how to drive, so you can't assign that car to me. A prohibited assignment is an assignment that basically cannot be made. And the first question we are going to do, we finished till question number 5. We start with question number 6. So let me write down the question. A, B, C, D. 5, 1, 2, 4, 7, 6, 4, 11, 14, 3, 3, 7, and lastly 6, dash 1, 5. What does this question say? Well, I have to solve this given assignment problem, but keeping in mind or bearing in mind that this assignment, and which is that assignment? The assignment where B is going to 6. B is going to S is an assignment that is prohibited or an assignment that is not allowed. How do you solve such a problem, knowing that just some time ago we said everybody should be capable of doing every job? So like I said, I'm going back on my word, everybody is not capable of doing every job. Now, if B cannot be given to S, this can be looked at in different ways, or people do all this on a prohibited assignment. Some people say, what are the numbers here? 14, 6, 5, 1, 6, 3. What principle does your assignment problem work on? Well, my assignment problem method assigns that job to that person, which in totality can be done in the least possible time. Okay. So your assignment keeps in mind that I have to assign the smallest value to everyone. Yes. Then do one thing, no? Give this value a very high number. What do you mean by a very high number? An extremely high number, which means 1,685,000. Well, that you can give. That is also a very high number, but a high number with respect to these numbers. If you notice, all these numbers are in the highest in their 20s. So they don't cross 20 basically. So the highest number that you see is 14. Choose a number which is very high compared to 14. Well, a number that is very high when compared to 14 is 100, 400, 800, 1000. So you write 1000 here, and it will always be made sure that B will never be assigned to S. Because then 1000 as compared to 163 is a very large number. That is one way. The second way is, some people say, don't put a number, just write a value M. What is the value M? Well, value M represents very high number, infinitely large number. And then solve the question. Well, some people say, put an infinity sign there. Some people say, put a dash there. So it doesn't matter. What I say is, why put a number there? Just keep a dash or keep an infinity sign, whatever you want to, and start solving the question. Treat it like that cell does not exist, and start solving the question. Step 1, row reduction. P, Q, R, S, A, B, C, D. What is the least in the first row? 5. 5 minus 5 is 0. 7 minus 5 is 2. 14 minus 5 is 9. 6 minus 5 is 1. Row number 2. What is the least? 1. Start subtracting. 1 minus 1 is 0. 6 minus 1 is 5. 3 minus 1 is 2. What is dash minus 1? Nobody cares. That cell is going to remain dash, irrespective. What is the least here? 1. Subtract throughout. 2 minus 1 is 1. 4 minus 1 is 3. 3 minus 1 is 2. 1 minus 1 is 0. And lastly, the least here is 4. 4 minus 4 is 0. 11 minus 4 is 7. 7 minus 4 is 3. And 5 minus 4 is 1. Row reduction is done. Check if every column has a 0. The first column has 3 zeros, not required. Second column does not have a 0, so required. So even if one column requires a reduction, you will do it. Step 2, column reduction. So P, Q, R, S, A, B, C, D. There is already a lot of zeros here, so does not require reduction, or in other words, the least is 0. Even if I subtract throughout by 0, it still remains the same. The least here is 2. 2 minus 2 is 0. 5 minus 2 is 3. 3 minus 2 is 1. 7 minus 2 is 5. The least here is 2. 9 minus 2 is 7. 2 minus 2 is 0. 2 minus 2 is 0. 3 minus 2 is 1. The least here is already 0. So no reduction required. 1 dash 0 1. Row reduction and column reduction is done. We move on to the third step, and that is assignment. So let's move on to step 3, and that is assignment. So I'm going to say step 3, assignment. Write down the entire matrix again and then only assign. So P, Q, R, S, A, B, C, D, 0, 0, 1, 0, 0, 3, 1, 5, 7, 0, 0, 1 and 1 dash 0, 1. Let's start assigning. First row, 2 zeros, can't do anything. Don't touch, go to the next. 2 zeros, can't do anything. Go to the next. 2 zeros, can't do anything. Go to the next. 1 0, yes, finally. So I'll repeat. 2 zeros, do not do anything. Only with 1 0 you will assign. 2 zeros, don't do anything. 2 zeros, can't do anything. 1 0, mark it as an assignment. Now in this row there was 1 0. In that column, cancel every other 0. But sir, now what? Well, you did this row wise, no? Now start doing it column wise. Column wise meaning in this column. Let's start with the first column. So the first column is already marked or cancelled. What about the second column? Well, in the second column, there is exactly 1 0, then mark it. Now in that row, if there is any other 0, cancel it out. No. Move to the next column. There are 2 zeros, then I can't do anything. Move to the next column. There is 1 0, which is 1 best, then give it. In that row, if there is any other 0, cancel it. I've done row wise, sir. I did column wise, but there is still 1 0 remaining. Fine. Go again row wise. You will keep doing this till all the zeros have been either marked or cancelled. Row wise, 2 zeros already marked or cancelled. Row wise, 2 zeros, but 1 is cancelled, which means only 1 0 remaining. Mark this as an assignment. In that column, cancel every other 0. So, let me quickly repeat this for you. Row wise, 2 zeros, can't do anything. 2 zeros, can't do anything. 2 zeros, can't do anything. 1 0, yes. In that row, I am marking the 0, which means I will cancel every other 0 in that column, which means that D can't go to anybody else. Is that right? Next, if you are done row wise, let's start column wise. Already marked or cancelled? There is exactly 1 0. If there is exactly 1 0, mark it. In that row, if there is a 0, cancel it out. There is no 0. Let's go to the next column. 2 zeros, can't do anything. Let's go to the last column. 1 0, mark it as an assignment. In that row, if there is another 0, cancel it. I did row wise, I did column wise, but there is still 1 0 pending. Again go row wise. You keep doing row examination, column examination, row examination, column examination. Row wise. 2 zeros already marked or cancelled. 2 zeros, 1 is cancelled, which means 1 is pending. Mark it as an assignment. Cancel every 0 in that column and you are done. One last time, but quicker. No explanations. 2 zeros cannot do anything. 2 zeros can't do anything. 2 zeros do not touch. 1 0, mark it as an assignment. In that column, cancel every other 0. If you are done row wise, start column wise. Done. 1 0, perfect. Mark it. In that row, cancel. In the next column, 2 zeros, can't do anything. 1 0, mark it as an assignment. In that row, cancel. Row wise, done. 1 0, mark it as an assignment. In that column, cancel. You are done. That's your final answer. And that is A, B, C, D, A, B, C and D. A is going to Q, B to R, C to S, and D to P. So Q, R, S, P, Q, R, S, P. If A goes to Q, A on Q takes 7, B on R takes 3, C on S takes 1, and D on P takes 4, which is a total of 10 plus 5 is 15 minutes, hours, whatever that is, that we haven't figured out, that we'll figure out when we're doing actual verbal questions. That's it. That's your answer. And if you notice, you had put a prohibition that B cannot go to S. I have made sure that B doesn't go to S. B is going to R. So my prohibition is also taken care of. That is how you do a prohibited assignment question. We move on. Another question, and that is also a prohibited assignment. This is question number 6. Let's move on to question number 7. Question number 7, A, B, C, D. Again, there is a prohibition. 1, 2, 3, 4. 1 is going to C, not allowed. 1 going to C is prohibited. Fine. Let me first write down the question. So A, B, C, D. 1, 2, 3, 4. So 5, 0, 7, 3. Then you have 4, 2, 6, 7. Then you have dash 4, 10, 2. And you have 4, 1, 4, 8. Done? Let's start solving. You have put in a prohibition where you are saying that 1 cannot do C. Now I have a humble request. You notice there is 1, 2, 3, 4. Now when you start reducing, no, some people in the flow of things, because very excited to do things, they see that the least is 1 and start reducing by 1. The least is 2 and least is 1. 2 minus 1 is 1 and so on. Please don't do that. This is not the values. This is the numbering for the rows. So this is what I do. I draw one line horizontally and one line vertically so that there is a bifurcation, that this is numbering and these are the values. So step 1, row reduction. A, B, C, D, 1, 2, 3, 4. Quickly draw your lines, or later there will be confusion. What is the least here? 4. Subtract throughout by 4. 1, 0, dash, 0. Again, I don't care what the value there is. Dash. If you want, some people put an infinity sign. Put an infinity sign and continue. Least is already 0. No reduction required. 0, 2, 4, 1. What is the least? 4. 7 minus 4 is 3. 6 minus 4 is 2. 10 minus 4 is 6. 4 minus 4 is 0. Least is 2. 3 minus 2 is 1. 7 minus 2 is 5. 2 minus 2 is 0. 8 minus 2 is 6. Does every row have a 0? Yes, I did row reduction. That was the idea of row reduction. Every row ends up having a 0. So every row has a 0. What about every column? Well, every column also has a 0. Oh, fantastic. Then column reduction is not required. Not required. So I'm making a note here that says that since every column already has a 0, column reduction is not required, which means we directly move on to the next step, and that is step fine. Step 2, assignment. So A, B, C, D, 1, 2, 3, 4. Write down as and how it is 1031 0225 dash 460 and 0106. Row wise. 2 zeros, can't do anything. Row wise. 1 0, mark it as an assignment. In that column, cancel if there is a 0, there's nothing. Row wise, mark it as assignment. In that column, if there is a 0, cancel it out. Row wise, mark it as an assignment. In that column, if there is a 0, cancel it out. There is nothing to cancel. Row examination done. Start column examination. Already cancel marked. 1 0, fantastic. Mark it as an assignment. Cancel anything in that row. Done. That's your answer. I'm going to quickly repeat it. And now henceforth I'm going to go faster with the assignment part. 2 zeros can't do anything. 1 0, mark it as an assignment. If there is a 0 in that column, cancel. There is no 0. 1 0, mark it as an assignment. In that column, cancel a 0. 1 0, mark it as an assignment. In that column, cancel the 0. Row wise done, column wise. Already marked. Mark as an assignment. In that row, cancel. Done. That's your answer. What is your answer? Well, your answer is 1, 2, 3, 4. One goes to B, so it's B, A, D, C. So it's B, A, D, C. If 1 goes to B, 1 going to B can be done in 4. Fantastic. So 4. 2 going to A. 2 going to A can be done in 0. 0. 3 going to D. 3 going to D can be done in 4. And lastly 4 going to C. 4 going to C can be done in 2. That's it. That is my final answer. 4 plus 4 is 8, plus 2 is 10. So this can be done in a minimum of 10 minutes, seconds, hours, rupees, whatever it is. And this is my assignment. You had put a prohibition, no? What was your prohibition? That 1 should not go to C. Well, I have made sure that I incorporate that. And my 1 has not gone to C. 1 has gone to B. Is that right? Let's move on to the next question. That was the second question in prohibited assignment. Question number 7. Let's move on to question number 8. Oh, there are like 2 prohibitions here. But that's okay. Anyway, what am I going to do? I'm going to put a dash there and not consider it. So how does it matter to me in any way? So let me quickly write down the question. And it's a 5 by 5 question. So 1, 2, 3, 4, 5 and A, B, C, D and E. The values are 9, 12, dash. Now in the place of dash I'm putting an infinity sign. I'm sorry, there was a little bit of a confusion with the numbering. This is question number 8. So question number 8 is 1, 2, 3 and A, B, C, D. So again, I'm going to go back on my words. I'm going to go back on the one basic thing that I said. 9, 8, 20, 21, 12, 13, 12, 15, and lastly 11, 17, 13, 17. Fine. So like I said, I'm again going back on my words. And what is that? I had told you that the number of jobs and the number of people have to be the same. Now, you have 4 jobs and only 3 people to do them. Or you have 3 jobs and you have 4 jobs and 3 people to do them. Or you have 4 people and 3 jobs. This is the next change in an assignment problem. And this problem is called an unbalanced assignment problem. An assignment problem is said to be balanced if the number of rows and the number of columns is the same. And I told you number of jobs and number of people have to be the same. If you have 10 cars, you need 10 drivers. If you have 8 cars, you need 8 drivers. If you have 6 horses, you need 6 jockeys to ride the 6 horses. Now that you have thrown this curveball at me, and that is, you have, let's say, 4 people and only 3 machines, how do I assign? I can't assign. And this is where step 1 is not going to be row or column reduction. Step 1 is going to be balancing the given problem. What are we going to do? We are going to balance the given assignment problem. How? What are you short of? Well, there are 4 rows but only 3 columns. Then do one thing, add another dummy column. Fine. A, B, C, D. Now are there equal number of rows and equal number of columns? Yes. Write down the values. 9, 8, 20, 21, 12, 13, 12, 15, 11, 17, 13, 17. But sir, what do I write here? 0. The dummy does not really require any values. And we are going to put the values as 0. But sir, if I put 0, one of them will get allocated to the dummy. True. And that I can't help. You only gave me, you gave me 4 workers with only 3 machines. Now one of the workers will get allocated to the dummy, which means that that worker should not work. That's it. I can't help that in any way. So we come to something called as an unbalanced assignment problem, where now I'm going back on my word one at a time, where initially I told you that the number of people and the number of jobs has to be the same. The number of cars and the number of drivers has to be the same. Number of people and number of machines have to be the same. And everybody should be capable of doing every job. First, I went back on my first declaration that there could be jobs that cannot be done by certain people. We put a dash there, we consider a prohibition there, and we move on. And there could be unequal number of people and jobs. In that case, whatever you are short of, add a dummy row or a column. Now here there was a column missing, then I added a dummy column. If there was a row missing, I would add a dummy row. Once you added a dummy column, the problem now is a balanced assignment problem. And if the problem now is a balanced assignment problem, I can start solving it. How? Step 1 row reduction, step 2 column reduction, step 3 assignment. So I will begin by saying step 1. Now the thing about a row reduced, the thing about row and column reduction is that we do a row or a column reduction if and only if there is not a 0. Now whenever the question is an unbalanced question, and that is You either need a dummy row or you add a dummy column. What happens is that, now if you notice, you look at this, you added a dummy column and all the entries in that column are 0. Now, look at this. This is going to be already a 0, already a 0, already a 0 and already a 0. And that is why in this row reduction is not required. We will move on to column reduction. What if I would add a row? If a row was added, then every column would already have a 0. So column reduction would not be required. Row reduction might be required. So please don't make a mistake of not considering the 0 and saying, oh, the least is 11, let's start reducing. Sorry, the least is 9, let's start reducing. That's wrong. There is already zeros, that is why we are not going to row reduce. So I am going to say, since every row already has a 0, row reduction is not required. So step 1 row reduction is eliminated. We move on to step 2 column reduction. So I move on to step 2, but for me it is going to be step 1. Step 1 column reduction. When I start doing column reduction, again, the first I will write down the A and the 1, 2, 3, 4. So this is going to be horizontally 1, 2, 3, 4. And A, B, C, D. Let's begin then. Column number 1. Least is 9. Least is 8. Subtract every value by 8. When I subtract by 8, I get 1, 0, 12, 13. Number 2, the least here is, well, the least here is 12. Subtract throughout by 12, 0, 1, 0, 3. So 0, 1, 0, 3. Number 3, the least here is 11. So 0, 6, 2, 6. 0, 6, 2, 6. 0 throughout. So 0, 0, 0 and 0. Step 1 row reduction is not required. Step 2 column reduction will be done. Yes, done. So every row and every column has a 0 now? Yes. Then we move on to step 3 technically, but in this case it is going to be step 2, and that is assignment. 1, 2, 3, 4. A, B, C, D. Write down these as and how it is. 1, 0, 12, 13, 0, 1, 0, 3, 0, 6, 2, 6, 0, 0, 0, 0. Now we can start assigning. Let's start assigning row wise. 3 zeros, can't do anything. You can only assign if there is one and only one 0 in that row or in that column. If you are going row wise or column wise. 3 zeros can't do anything. 2 zeros cannot do anything. 2 zeros cannot do anything. 1 0, yes, I can mark it. Repeat. 3 zeros can't do anything. 2 zeros can't do anything. 2 zeros can't do anything. 1 0, perfect. Mark it as an assignment. I was going row wise, then I will cancel all zeros in that column. Let's continue. All rows are done. Let's do column wise. First column, only 1 0, perfect. Then mark it as an assignment. Now in that row, if there is any other 0, cancel it. No other 0. There is 1, but it's already cancelled. Column number 2, 2 zeros. Like I said, I can't do with 2 zeros. Column number 3, exactly 1 0. Mark it as an assignment. In that row, any other 0 has to be cancelled. Last column, already marked or cancelled. I'm done row wise, I'm done column wise, but there is still zeros pending. Again start row wise. Done, done, exactly 1 0. Well, there are 2, but this is cancelled, so it doesn't matter. Mark it as an assignment. In that column, cancel all other zeros. That's it. I'm going to quickly repeat because we are not sitting face to face. So if at all you need a repeat, I'm going to do it for you. 3 zeros can't do anything, 2 zeros won't do anything, 2 zeros won't do anything. 1 0, mark it as an assignment. In that column, cancel all out zeros. This is row wise. Let's go column wise. 1 0, mark it as assignment. In that row, cancel all other zeros, but already cancelled. 2 zeros can't do anything. 1 0, mark it as an assignment. In that row, cancel out all other zeros. Done. Already marked or cancelled. Let's go row wise. Already marked or cancelled. Already marked or cancelled. 1 0, mark it as an assignment. In that column, cancel out all other zeros. That's it. This is my final answer. And my answer is A, B, C, D. A goes to 3. B goes to 1, C goes to 2, and D goes to 4. But 1 minute, what is 4? Well, 4 is the dummy column. They gave it to you. No, I introduced it because I couldn't solve the problem. Then do they care what this dummy is? They don't really care. Then you don't really need to mention this. It's by default that D won't be going to anyone. If you want to write down, you can write it down that D goes to 4, which is a dummy. And then write down 1 going to 3. Sorry, A going to 3. A going to 3 is 11. B going to 1 is 8. And C going to 2 is 12. The total is 12 plus 8 is 20. 20 plus 11 is 30. Sorry, this is 0. 31. And this is how you solve an unbalanced assignment problem. So for now, we saw 3 things. Number 1, how to solve a basic problem. Number 2, how to solve a restricted or a prohibited assignment. And number 3, how to solve an unbalanced problem. Let's move on to the next question. What is the next question? That was question number 8. Let's move on to question number 9. What is question number 9? A, B, C, D, E and 1, 2, 3, 4. Fine. Let me write that down. A, B, C, D, E, 1, 2, 3, 4. 9, 12, dash, I am putting an infinity sign there, 14. 11, 9, 11, 8. 15, infinity, 14, 12. 10, 10. 11, 7, and lastly 11, 9, 7, 8. Done? Yes. Question number 1. Now later, once we do everything, then I will tell you what questions are you supposed to ask. But for now, looking at the question, number one, you see two prohibitions or you see two restrictions, and that is 2 cannot be assigned to C and 3 cannot be assigned to A. Okay, so let me do one thing to create a stark bifurcation. Another thing that you notice is that we have 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns. Doesn't that imply that my assignment problem is unbalanced? I have one less row. So I am going to say step 1, balancing the assignment problem. A, B, C, D, E, 1, 2, 3, 4, 5, and this 5 is basically a dummy row. So I have 9, 11, 15, 10, 11, 12, 9, infinity, 10, 9, infinity, 11, 14, 11, 7, 14, 8, 12, 7, 8, 0, 0, 0, 0 and 0. I have added a dummy row and made this problem a 5 row, 5 column problem. The problem is balanced. Fantastic. We start with step 2. Step 1 is done. Step 2. And what is step 2? Step 2 is row reduction. You always start with row reduction. Row reduction, column reduction, assignment. Is row reduction required? Yes. Column reduction might not be required because every column already has a 0. So step 2, row reduction. So I am going to say A, B, C, D, E, 1, 2, 3, 4, 5. Row wise, the least here is 9. 9 minus 9 is 0. 11 minus 9 is 2. 15 minus 9 is 6. 10 minus 9 is 1. 11 minus 9 is 2. The least here is 9. 12 minus 9 is 3. 9 minus 9 is 0. Infinity minus 9 is infinity. 10 minus 9 is 1. 9 minus 9 is 0. The least here is 7. Infinity. 11 minus 7 is 4. 14 minus 7 is 7. 11 minus 7 is 4. 7 minus 7 is 0. The least here again is 7. 14 minus 7 is 7. 8 minus 7 is 1. 12 minus 7 is 5. 7 minus 7 is 0. 8 minus 7 is 1. And the last row already has a 0. So reduction is not required. Step 1 row reduction is done. Step 2 column reduction. Well, in this case, step 1 was balancing. Step 2 was row reduction. Step 3 will be column reduction. But do you notice every column already has a 0? So what am I going to do? I am going to say that since every column already has a 0, column reduction is not necessary. So what do we move on to? We directly move on to the next step, and now it will be step 3, and that is assignment. So step 3, assignment. What do I have? Well, I have A, B, C, D, E and 1, 2, 3, 4, 5. A 0, 3, infinity 7, 0, 0, 3, infinity 7, 0. Let me copy that down directly. 2, 0, 4, 1, 0, 6, infinity 7, 5, 0, 1, 1, 4, 0, 0, 2, 0, 0, 1, 0. Done? We start with the next step, and that step, like I said, is assignment. So we start assigning now. How? Basic rule. You start examining every row first. So start row examining. If there is exactly 1 0, mark it as an assignment. If not, then move on to the next row. Is that right? So we begin with row examination. In this row, exactly 1 0, fantastic. Mark it as an assignment. In that column, cancel everything else. In this row, 2 zeros, don't do anything. Do not touch. In this row, exactly 1 0, mark it as an assignment. In that column, cancel out everything else. In row number 4, there is exactly 1 0, mark it as an assignment. In that column, cancel everything else. In row number 5, there are 2 zeros. I can't really do anything. Let's start column wise. Already marked or cancelled. 2 zeros, I can't do anything. 1 0, I mark it as an assignment. In that row, if there is any other 0, I will cancel. Already marked or cancelled. Already marked or cancelled. Row wise done. Column wise done. Again row wise. Done. Exactly 1 0. Mark it as an assignment. In that column, if there is a 0, cancel it. Already cancelled. Done, done and done. That's it. I'll repeat this quickly. Let's start row wise. 1 0, mark it as an assignment. Then in that column, if there is a 0, cancel it out. Obviously, there will not be another 0 in the row, because we've already checking rows with one and only 1 0. So if there is a 0, there has to be a 0 in the column. Cancel it out. 2 zeros, can't do anything. 1 0, mark it as an assignment. In that column, cancel it out. 1 0, mark it as an assignment. In that column, cancel it out. 2 zeros cannot do anything. Let's start column wise. 2 zeros already marked or cancelled. 2 zeros cannot do anything. 1 0, mark it as an assignment. In that row, if there is a 0, cancel out. Done, done. Row wise done, column wise done. Let's go back row wise. Done. 1 0, mark it as an assignment. In that column, if there is a 0, cancelled out. Already done. That's my answer. 1, 2, 3, 4, 5. 1 goes to A, 2 goes to B, 3 goes to E, 4 goes to D, and 5 goes to C. Now if 1 goes to A, that can be done in 9 rupees minutes, whatever that is. If 2 goes to B, again 9. If 3 goes to E, 7. If 4 goes to D, 7. And 5, well, there's nothing like 5. It's a dummy row. So if 5 is going to C, it means that if these are men and these are machines, then there is nobody to work on machine C. Machine C will be unmanned. But then it's a dummy. We write a 0, and that is why we don't mention it most of the cases. Because it's not something that they gave us, it's something that we introduced. Let's take a total. 9 plus 9 plus 7 plus 7 plus 0 is a total of 32. Hours, minutes, days, whatever it is. That is question number 9. We move on to the next question. Question number 9 that was. We now come to question number 10. Now question number 10 says multiple optimal solution. Ignore that for the time being. I will write down the question. Luckily here 4 rows, 4 columns, so it's balanced. Number of people and number of jobs is the same. So I don't really need to worry about it. Fine. Let me quickly write down the question. There is A, B, C, D, and there is 1, 2, 3, 4. So, question number 10. 1, 2, 3, 4. And A, B, C, D. 120, 80, 110, 90, 100, 90, 140, 90, 80, 110, 120, 80, 90, 70, 100 and 90. This has come out to be a little too close. Let me draw columns so that you understand the difference. Fine. So I will make my standard assumptions. Everybody can do every job. All jobs are balanced, which means the number of people doing the jobs and the number of jobs is the same. Fine, then we do this normally, just that the values are big. Apart from that, nothing else changes. So we start with step 1, row reduction. So we have 1, 2, 3, 4, A, B, C, D. Row reduction. The least in the first row is 80. Subtract throughout by 80. 120 minus 80 is 40. 100 minus 80 is 20. 80 minus 80 is 0. And 90 minus 80 is 10. Number 2. Subtract throughout by 70. That's the least. 80 minus 70 is 10. 90 minus 70 is 20. 110 minus 70 is 40. 70 minus 70 is 0. Subtract throughout by 100. 110 minus 100 is 10. 140 minus 100 is 40. 120 minus 100 is 20. And 100 minus 100 is 0. The least here is 80. 90 minus 80 is 10. 90 minus 80 is 10. 80 minus 80 is 0. And 90 minus 80 is 10. Row reduction is done. Check if every column also has a 0. Well, the first column itself does not have a 0. So even if one column doesn't have a 0, I have to do entire column reduction. So I'm going to go again and say 1, 2, 3, 4, A, B, C, D. What is the least in the first column? Well, the least in the first column is 10. 40 minus 10 is 30. 10 minus 10 is 0. 10 minus 10 is 0. 10 minus 10 is 0. The least here is 10. 20 minus 10 is 10. 20 minus 10 is 10. 40 minus 10 is 30. 10 minus 10 is 0. Already a 0. So no reduction required. 0, 40, 20, 0. Already 0. So 10, 0, 0, 10. Sorry, I forgot to write. This would be step 2. Column reduction. Step 1 row reduction. Step 2 column reduction. Done. Step 3 assignment. For assignment, I am going to rewrite the entire matrix. I don't want to create chaos in that one. So 30, 0, 0, 0, 10, 10, 30, 0, 0, 40, 20, 0, 10, 0, 0, 10. Let's start assigning. Row wise, exactly 1, 0. Fine. Mark it as an assignment. In that column, cancel out every other 0. Row wise, 2 zeros, I am not allowed to touch. Row wise, 2 zeros, not allowed to touch. Row wise, 2 zeros, not allowed to touch. Okay, let's go column wise. 3 zeros, cannot do anything. 1 0, perfect. Will be marked as an assignment. Row wise, I will cancel everything else. Already marked or cancelled, 2 zeros cannot do anything. Let's start row wise. 1 0 already marked. 2 zeros cannot do anything. 2 zeros cannot do anything. Already marked. Fine. Let's go column wise. 2 zeros cannot do anything. Already done. Already done. 2 zeros cannot do anything. What? Fine, let's go row wise. Done. 2 zeros cannot do anything. 2 zeros cannot do anything. Already done. Okay, let's go column wise. 2 zeros cannot do anything. Already done. Already done. 2 zeros cannot do anything. If you realize, you keep going around in circles. The problem is, because there are 2 zeros in every row and 2 zeros in those 2 columns, you are not able to give a proper solution to this, and this keeps going in circles. So let me do one thing. Let me once again try to show this to you and then tell you where do we get stuck. Row wise, 1 0, mark it as an assignment. In that column, cancel out every other 0. Row wise, 2 zeros cannot do anything. 2 zeros cannot do anything. 2 zeros cannot do anything. Column wise, 3 zeros cannot do anything. 1 0, perfect. Mark it as an assignment. I am going column wise. Cancel every other 0 in that row. Already done. 2 zeros cannot touch. Let's start doing row wise. Done. 2 zeros cannot do anything. 2 zeros cannot do anything. Done. Column wise. 2 zeros cannot do anything. Done. 2 zeros. Done. 2 zeros cannot do anything. Do you realize that we keep going round in circles? Because these 4 zeros are forming a loop, because of which neither is getting assigned nor is getting cancelled. And so what we are going to do is we are going to randomly assign any 0. Okay, so I am assigning this 0. 1 minute. But there are 2 zeros you are still assigning. Obviously, sir, because it keeps going in a loop. I can't do anything. Okay. Then do one thing. Then cancel the 0 in that row and cancel the 0 in that column, because that can't go to anybody else. And then this 0 is the only one left. It gets assigned. So let me do one thing. Let me do the assignment again for you, but now with this little twist. 1, 2, 3, 4. A, B, C, D. 30, 0, 0, 0. 10, 10, 30, 0. 0, 40, 20, 0. 10, 0, 0, 10. Let's start. Row wise, 1, 0, mark it. In that column, cancel. 2 zeros cannot do anything. 2 zeros cannot do anything. 2 zeros cannot do anything. Column wise, 3 zeros cannot do anything. 1, 0, mark it as an assignment. In that row, cancel every other 0. Done. 2 zeros cannot do anything. Row wise, done. 2 zeros, done. Column wise, 2 zeros, done, done, 2 zeros. Well, this keeps going in a loop. So I randomly choose any 0. 1 minute. Last time you chose this 0, no? What if I would have chosen this 0? That is also allowed. But sir, the assignment will change. I agree. Continue, no? If I choose this 0, then what happens is I will have to cancel this and cancel this 0 in that row and in that column. All other zeros will be cancelled. So then this 0 will get assigned. My answer in this case would be A, B, C, D. A goes to 3, B goes to 1, C goes to 4, and D goes to 2. While my answer in this case, A, B, C, D, would be A is still going to 3. But B in this case is going to 4, C is going to 1, and D is going to 2. Will my answer change? Well, evidently your answer has changed. A and D remain the same, but B and C values, answers are changing. Okay, then the values will also change. Well, probably. Let's check. A going to 3 is 80. Fine. A going to 3 is 80. So here and here it will be 80. D going to 2 is 90. So here also it will be 90 and here also it will be 90. B going to 1 will be 80. And C going to 4 will be 100. B going to 4 will be 70. C going to 1 will be 110. If I now take a total, the total will be 80 plus 80 plus 100 plus 90 is a total of 350 here. And here the total is 80, 70, 110 and 90 is a total of 350 here. Do you realize that although these are two different assignments, both the assignments give the same total? And that is why this question comes under a section called multiple optimal solutions. What does that mean? Up till now, I was getting an optimal solution. What do you mean by optimal? Optimal means best. And there was no confusion. That one solution is the best solution. And I told you, you make the assignment any other way, you will not get the same answer. You will get more than what you have gotten out of this solution. Every other assignment will be more than 31. Here, 350 is the best. You will never get an assignment that will give you a total less than 350. But there are two such assignments that give you that best. And this will happen if there is a loop. Whenever in the rows and the columns there are zeros everywhere, row wise or column wise, you have to keep skipping. And you keep going into a loop. To break that loop, you randomly choose any one zero, cancel out the rest and continue. Like here, I chose this zero. So usually I choose a row with only one zero, but I chose a row with two zeros because I didn't have a choice. Then I cancel the zero in that row and the zero in that column. That leaves me with one zero here. I mark it as an assignment. Or I either choose these two or I choose these two and cancel these two. This comes under a section called a multiple optimal solution assignment problem. There is more than one solution that is optimal. There is more than one best solution. And this is the next thing that I wanted to introduce, and that is a multiple optimal solution. So we have studied a normal assignment problem, then an assignment problem with a prohibition, then an assignment problem that is unbalanced or an unbalanced assignment problem, and now we finally come to a multiple optimal solution assignment problem. Let's move on and see what else do we have in stores for us. That was question number 10 if I am correct. Let's move on to the next question number 11. From question number 12 now, there's something very odd written. It says solve the following maximization problem. What does that mean? Now the good thing is that there are only how many? 3 rows and 3 columns. Let me write down the question. The question says A, B, C, 1, 2, 3, 13, 14, 16, 11, 12, 15 and 13, 12, 14. And I am asked to solve the following maximization problem. What does that mean? Well, what it means is that I have to now assign. Up till now what was happening? I was assigning in such a way that the total job was getting done in the least possible time or the least possible cost. Is that correct? Yes. But now they are asking you to maximize the given problem. What do you mean by maximize the given problem? Here, when I did complete enumeration, there were 6 ways of doing this, out of which the least was 10. And by solving also, I got the same answer. Here also, there were 6 choices, out of which the least was 18. And when I used the Hungarian method of solving an assignment problem, my answer was also the same. My answer and their answer was the same. Here, by the assignment problem model, also I got the same answer, which is P going to 2, Q going to 1 and R going to 3. And the final answer was 18. Now in this question, you are asking me to maximize. If I start solving this question with my method, which is the Hungarian method of solving an assignment problem, the problem that will arise is this will give me a solution in such a way that I will get an assignment where the total value of the assignment will be the least. But they gave me something called as maximize the assignment problem. So you want a maximum out of this assignment problem and not a minimum. So you are trying to tell me that this data given to me is not time or cost that needs to be reduced. It is profit. It is sales. Let's say these are advertisements and these are the media in which I am advertising. And if this is the exposure, if ad 1 is put into media A, I get 13 lakh people who will reach the ad. If ad 1 is given out in media B, then 11 lakh people will get to see the ad. In such a case, this exposure I want to be high. I don't want it to be low. If I solve this using my assignment problem module, it will give me a minimum answer and not a maximum answer. So what do I do? Well, let me do one thing. Let me solve this question, but by complete enumeration, which is I am going to write down each and every method of assigning here and then find a total of that assignment. 1, 2, 3, 4, 5, 6. Correct? So I have a choice. Let 1 do A, 2 do B, 3 do C. Or let 1 do A, 2 do C, 3 do B. Or BCA or BAC or CAB or CBA. Let's start finding out the total of this allocation. If 1 goes to A, 13, 2 goes to B, 12, and 3 goes to C, 14. If 1 goes to A, 13, 1 goes to B, 11 and 11, 1 goes to C, 13 and 13. If 2 goes to C, 2 goes to C, 12. If you notice here also 2 is going to C, 12. 3 goes to B, 3 goes to B, 15. 3 goes to B, 15. Then I have 2 going to A. 2 going to A is 14 and 14. And 2 going to B is 12. 3 going to A is 16. 3 going to C is 14. And 3 going to A is 16. Let me take a total. I'll do that in the calculator. And that will be 13 plus 12 plus 14 is a total of 39. 13 plus 12 plus 15 and the answer is 40. 11 plus 12 plus 16 and the answer is 39. 11 plus 14 and the answer is 39. 13 plus 14 plus 15 and the answer is 42. And lastly 13 plus 12 plus 16 and the answer is 41. So there are two things here. Number one, the assignment that gives the least answer. Now the least is this 39, which is seen in a lot of places, but that's okay. It's seen in 3 places, 1, 2 and 3. So this is a multiple optimal solution question. There are a lot of leasts. Okay, I know the least is 39. and the highest is 42. What does that mean? If I use the method that I'm using, step 1 row reduction, step 2 column reduction, step 3 assignment, and solve, my answer will either be this or this or this. Whatever that is, the total of my answer will be 39, 39 and 39. But does the problem want me to minimize? No, it wants me to maximize. It doesn't want the minimum value. It wants the maximum value. And the solution that gives you the maximum value is 42, which is 1 going to C, 2 going to A and 3 going to B. The question is, how do I force my question to give me a maximum answer instead of a minimum answer? Because my method is structured to give me a maximum value and not a minimum value. My structure is made to give me a minimum value and not a maximum value. And this is where we come to, if the objective is maximize, you cannot maximize. So in this case, your first step is going to be changing the objective of the question. What do you mean by changing objective? What is your objective? Maximization. I can't solve it. Hungarian method only and only minimizes. It does not maximize. So if you want me to maximize, I will have to change the objective and change the objective to minimize. How will I do that? Well, I'll give you the different ways of understanding it. I'll give you an example. I have 3 workers, A, B and C. I'll tell you how psychology works or how basic common sense works and how does this problem work. I have 3 workers, A, B and C. The cost of these workers working on a certain machine. So it costs A 10 rupees to work on a machine, B 4 rupees to work on a machine and C 20 rupees to work on a certain machine. My question to you is, listen to me properly. My question to you is, or let's say this is time. The time taken by A on a certain machine is 10, B on a certain machine is 4 and C on a certain machine is 20. My question to you is, who do you choose? I'll obviously say I choose B. I'm not stupid. Lesser the better, no? This guy does the job in 4 minutes. Best. Okay. That is the brains that you used. A, B, C. When A works on a certain machine, B works on a certain machine and C works on a certain machine, I'm giving you profits. When A works on a certain machine, I get a profit of 4 rupees. When B works on that machine, I get a profit of 2. And when C works on that machine, I get a profit of 6. My question to you is, who do you choose? Well, obviously, when it was time, least is good, it's profit, best, highest is the best. So I will choose worker C. Agreed. Nothing wrong with it. Fantastic. The problem is, if I do this in an assignment problem, my answer and assignment problem's answer will be the same. Because both of us are thinking in the same way. Time, least is good. But if I do the same with this question, my answer practically will be C, which is 6. Because profit, more is better. But when you ask assignment problem to do this question, assignment problem doesn't understand the meaning of these numbers. It doesn't care. It only understands one thing. You give me a number, least is the best. Assignment problem will choose B and not C. Now the problem is, I can't change the way assignment problem thinks. So I am going to change the way the question is put out. For this, so that assignment problem also chooses C as the answer, I am going to do something called as calculating opportunity lost or opportunity cost. What does that mean? I'll give you a very simple example. Whenever we were in school, or even now, right now you all are still studying, we are in colleges and doing professional courses. If there is a paper and you do very bad in it, so let's say out of 100 you get, let's say, a 50, and your parents say इतना कम क्यों मिला? You will say paper ही tough था, सबको कम आया. अच्छा, शर्मा जी के बेटे को कितना है? उसको 85 आया. उसको 85 आया, 100 नहीं आया, मैं समझ सकता हूं. आपको 100 नहीं आया, ठीक है. उसको 85 आया तो आपको तो 85 आना चाहिए था ना. 85 क्यों नहीं आया? And that is exactly what we are going to do here. These are profits. What is the highest profit? 6. Who made it? C. So my question to you is, if all of us are working in the same environment, आपको सेम जगह ट्यूशन के लिए भेजा था, सेम कॉलेज जाते हो, घूमते फिरते भी एक साथ हो, तो उसको क्यों ज्यादा मार्क्स आए? If C is capable of producing a profit of 6, everybody should be capable of producing a profit of 6. Is A capable? No. A is producing a profit of only 4. Then my question to you is, how many opportunities is A losing? Well, to reach a profit of 6, A is losing 2 opportunities, or in other words, 6 minus 4, which is 2. To make a profit of 6, how many opportunities is B losing? Well, B is losing 4 opportunities. To make a profit of 6, how many opportunities is C losing? C does not lose any opportunities. C is grabbing all opportunities and giving me the best profit. This is an opportunity cost or an opportunity lost value. Now, if I ask you to choose, who will you choose? Where I will say C, because C has lost minimum number of opportunities. If I ask assignment problem to choose, assignment problem will also choose C, because all assignment problem understands is सबसे कम है तो best है. According to assignment problem also 0, which is C, is the answer. According to me also 0, which is C, is the answer. So what I do is I change a profit table to an opportunity lost table, and lesser the opportunity cost, more the profit. जितनी कम opportunities lose करोगे उतना ज़्यादा profit मिलेगा. So if you understand this, let me come back and solve the question for you and show you that if you understand this and if you understand how it works, my answer after solving it should be 1 going to C, 2 going to A, and 3 going to B, which is a total of 42. This is your table. What is the objective? Not to minimize, it's to maximize. Assignment problem cannot maximize. Assignment problem can only minimize. So I am going to say step 1 in this case is not going to be row or column reduction. Step 1 is going to be changing the objective, क्योंकि आपका ये जो maximization वाला objective है ये मुझे समझता नहीं है. How will you change the objective? Well, this is what I'm going to say. Select the most maximum value from the entire matrix and subtract it from every other value. So A, B, C, 1, 2, 3. What is the most maximum profit? 16. Well, if 3 working on A can give me a profit of 16, everybody should be capable of giving me a profit of 16. Can you tell me how many opportunities is everybody losing? Well, 1 on A is 13. To reach 16, it is losing 3 opportunities, or 16 minus 13 is 3. 16 minus 11 is 5. 16 minus 13 is 3. 16 minus 14 is 2. 16 minus 12 is 4. 16 minus 12 is 4. 16 minus 16 is 0. 16 minus 15 is 1. 16 minus 14 is 2. I have changed my objective from a maximization to a minimization. Minimum opportunity lost will give me maximum profit. And now I start solving the question. Step 1 has become changing objective. Then step 2 will now become what? Step 2 will now become row reduction. A, B, C, 1, 2, 3. Least in this row is 3, 0, 2, 0. Least in this row is 2, 0, 2, 2. Least is already 0, 0, 1, 2. Every row has a 0. Does every column has a 0? Let me check. Yes? No. Then let's go to step 3, column reduction. A, B, C, 1, 2, 3. In this row, there are 2 zeros. In this row, column reduction. This column already has a 0. This column, least is 1. 2 minus 1 is 1. 2 minus 1 is 1. 1 minus 1 is 0. This column already has a 0. So 0, 2, 2. Does every row and every column have a 0? Yes. Then we move on to step 4, and that is assignment. So I have A, B, C, 1, 2, 3, 0, 0, 0, 1, 1, 0, 0, 2, 2. Row wise, 2 zeros can't do anything. Row wise, 1 0, mark it as an assignment. Cancel every 0 in that column. Row wise, 1 0, mark it as an assignment. Cancel every 0 in that column. Row wise done. Do column wise. Cancelled, 1 0, mark it as an assignment. Are either all zeros marked or cancelled? Yes. What is the answer? The answer is 1, 2, 3. 1 should go to C, 2 should go to A, and 3 should go to B. So C, A, B, was that the answer? C, A, B, that was the answer. 1 going to C will be how much? Now understand, this table you made to solve it or bring it in the assignment frame. They didn't give you this table. What did they give you? They gave you this table. So final answer will be applied in the original table. So 1 going to C is 13. 2 going to A is 14. And 3 going to B is 15. 13 plus 14 plus 15 is going to be 13 plus 14 plus 15 is 42. That's my answer, which is the most maximum. Didn't I change the way the process looks at the problem? And this is the last one thing that you need to know about an assignment problem, and that is changing the objective of an assignment problem. Was that the answer? CAB? Yes. 42? Yes. 1 goes to C, 2 goes to A, 3 goes to B for a total of 42. And this is what you do to solve an assignment problem. So henceforth, if an assignment problem is written in front of you, you are going to do something called as a preliminary check. What is a preliminary check? Preliminary or a prerequisite, something that has to be done first. Secondary is something that can be done later. Preliminary or prerequisite is something that has to be done before. You will ask yourself 3 questions. Question number 1. What is the objective of the problem? If it is minimization, fantastic. So if the data given to you is money or it is time which has to be reduced, fantastic. Start solving. But if the data given to you is profit or it is sales or it is exposure, profit or sales or exposure, or let's say cricketer and runs. If it is runs, more the better. And if that is the case, I will have to change the objective by changing the maximization objective to an opportunity cost or an opportunity lost matrix. Lesser the opportunity cost, more the profit. So if the objective is minimization, go to step 2. If it is maximization, change the objective and then go to step 2. Step 2 is the problem balanced? Which means, is it an n cross n matrix? Is the number of rows equal to the number of columns? If yes, fantastic. Problem is balanced. Move ahead. If not, add a dummy row or add a dummy column and balance the given problem. You might need 1 dummy row, or you might need 2 dummy rows, or you might need 1 dummy column, or you might need 2 dummy columns. Anyway, as and how required. But remember one thing, in the same question, you won't require 1 dummy row and 1 dummy column. Both will not be required. Then you are playing with yourself. Don't do that. If the problem is balanced, move on. If not, add a dummy row or a column to balance it. And then ask yourself, question number 3. Is there a prohibition? That is there anywhere written that this person can't do this job or that person cannot do this job? Now at your level, I have always seen this, that if there is a prohibition, no, they starkly write it in the table that there is a prohibition. When we used to do problems, our teachers used to be a little more intelligent. What they used to do, no, they used to write everything. And verbally in the question somewhere, they would write that due to technical difficulties, Q cannot be assigned to 3. Now, if you are somebody who quickly writes down the matrix and starts solving it, you will not include that prohibition. You will start solving the question. And that is why read the question properly and check if there is a prohibition. Now, in my questions where we were doing basics, I told you if there is a prohibition or not. Sometimes they put a value at the prohibition, but separately write down that due to technical problems, although there is a cost given, we cannot do that assignment. Once all 3 of your questions are answered, you can move on to row reduction, column reduction and assignment. And this is how an assignment problem is solved. With this, I'm going to end this session. In the next session, we are going to begin with more problems. Thank you very much. I'll see you in the next session.